follow Nakamoto consensus. However, Ethereum is moving to Ethereum 2, which will be a proof of stake sharded blockchain. Sybil attacks are prevented due to protocols like proof of work and proof of stake. 51% attacks grow increasingly harder with the size of blockchain, so you should run a node. Consensus is the mechanism that allows a blockchain to agree upon what the state of the blockchain is. Sharding and rollups are solutions to scalability issues on layer 1s. A layer 1 is any base blockchain implementation, like Bitcoin or Ethereum. A blockchain scalability problem is that there's not always enough block space for the amount of transactions that want to get in them. This leads to very high gas prices. And again, gas prices are how much it costs to interact with a blockchain. Whew. So we've learned a ton in this video so far. Everything that you went over is going to make you 10 times better as a developer. Because yes, being a good developer means you understand the code at a very technical level. But if you can understand the overall architecture as well, you can make informed decisions about how to architect your design or how to build your software in however you want to do so. So with all that being said, it's finally time to jump into some Solidity and jump into some code. So let's do this.
Now again, in the description of this video, there is a link to this GitHub repository. That's going to be the home base for all the code that we work with in this tutorial. We scroll down to this main section, this README, there's a table of contents in here. We can go to lesson 1, simple storage, and we'll have links, helpful tips, the itinerary of what we're going to learn, and everything else that you need to work with here. All the code that we're going to be working with is located in this simple storage link that we can go ahead and click. It's in its own different repository. We can go ahead and click the file to see all the code that we're going to be working with. So let's jump into it. Additionally, back in our full blockchain Solidity course, right at the top, there's this resources for this course section. If you have questions, engaging in GitHub discussions, Stack Exchange Ethereum, and Stack Overflow are going to be great places to get help and get support. I highly recommend making a Stack Overflow, Stack Exchange Ethereum, and a GitHub account so you can participate and engage with the community. Welcome to the Remix IDE, or the Remix Integrated Development Environment. This is going to be where we're starting to teach you how to work with Solidity and work with smart contracts and deploy to blockchains. We're going to use Remix to get us up to speed, as it has a lot of nice features that allow us to really see and interact with blockchains and really see what's going on. But eventually, we're actually going to move off of Remix to another platform. But all the Solidity that we're going to learn here obviously is going to apply everywhere as well. When you come to Remix, there's a whole lot of different plugins like Solidity, Learn ETH, Solhint Linter, and a whole bunch of other plugins as well. I'm going to go ahead and start by clicking the Solidity plugin, but we're not going to use any of these plugins for now, but later on you can kind of go back and learn a little bit more about what these plugins do. So let's start perusing. Let's start coding some things. On the left-hand side over here is where we're going to interact with everything. So let's go ahead and click the files up here. Now you can always go back and peruse this a little bit more. And in fact, I highly encourage you to, because that's how you're going to learn the most, the quickest. But for us, we're actually just going to go ahead and start with our own brand new file. We're going to create a little application that can store information on the blockchain for us. And this is our first project that we're going to do in Solidity. So we're actually going to create a new file, and we're going to call it simple storage.sol. All Solidity has an extension of .sol at the end. It stands for Solidity. Now let's take inventory of what we're going to be working with here. This is the Solidity compiler tab. It compiles all the Solidity code down to machine understandable code, or machine language here. There's a whole bunch of different parameters we can choose when working with Solidity. We can choose the compiler version, we can choose the language, which we're only going to be working with Solidity, the EVM version, don't worry about this for now. So let's code our first Solidity contract here. Now we are going to use something a little bit special here. When we actually deploy these, we're going to use a JavaScript virtual machine. So we're going to use a virtual machine that's going to simulate actually deploying to a testnet or a real network. We're not actually going to deploy on a real network. We will in a little bit. But just to get started, we're going to work with a JavaScript VM, which is kind of a fake environment for now, okay? Testing locally and understanding how to test locally will make your coding experience a lot faster. As you saw, when we sent some transactions, some of them actually took a lot of time to actually deploy. We don't want to have to spend that much time waiting around for our tests to actually finish, so we're going to use a JavaScript VM to kind of dummy it for now. But let's just start coding and go from there. So the first thing that you're going to need in any Solidity program is the Solidity version. So that's always going to be at the top of your Solidity code. It's defined by doing pragma, Solidity, and the version. We're going to be using some version between 0.6.0 and 0.9.0. So we're saying we want to use anything between 0.6 and 0.9. And as a force of habit, I just automatically hit Command S whenever I write anything. So that's why you saw some of this pop up here. Hitting Command S or Control S, depending on if you're Windows or not, we'll hit this compile button and we'll compile everything for us. Now, if we want a specific version of Solidity, we can also do 0.6.0. And if I go ahead and hit Command S or compile, our compiler will automatically revert to 0.6.0. However, if I try to do 0.8.0 with my Solidity at 0.6.0, it's going to give us an error. It's going to say the source file requires a different compiler version. We're using 0.8.0 and this is 0.6.0. So we're going to go ahead and hit compile and it's going to automatically move down to 0.6.0. We can also do caret 0.6.0 and this will allow us to work with really any version of 0.6. It'll work all the way up to 0.7, where if we hit Command S or Control S there, it'll give us an error. So this only works with any version below 0.7 and above 0.6. We're going to be using version 0.6.6. However, in future contracts that we work with, we're actually going to work with different versions of Solidity. The reason we're going to be changing versions throughout this course is that Solidity is a constantly updating language. Being good at switching between versions is going to make you an incredibly powerful smart contract engineer. The next thing that we're going to do is we're going to define our contract. So contract is a key word in Solidity, which stands for our smart contract that we're going to create. You can think of a contract similar to a class in Java or any other object-oriented programming language. So we're going to give our contract a name here. We're going to call it simple storage. And we're going to add this little curly bracket to say this is the contents of our contract simple storage. And I went ahead and hit Command S and we can see it is compiling successfully. You could hypothetically deploy this right now and this would be a valid contract. So great job for making it this far. Now in Solidity, there are many different types that we can work with. Let's go into some of the types of Solidity. We can have integers, aka whole numbers. They can be uint, as in an unsigned integer, meaning they're not positive or negative. We can also have an int, and we would define a variable by doing uint 256 favorite number equals 5. So we have an unsigned integer. Uint 256 means this is an integer of size 256 bits. So we can have this number be up to 256. You can also do uint favorite number equals 5, but if you want to be a little bit more precise, a lot of protocols and a lot of smart contracts will do the whole name like uint 256. We can also have booleans. Booleans are true, false. So we can have boolean favorite bool equals true. So this favorite bool would be true. It could also be false. We can have strings. String favorite string equals string. A string is a string of text here, right? It's going to be some word or phrase or really any of these keystrokes here. Similar to the unsigned integer, we can have an int 256. Favorite int equals -5. So it could be positive or negative. We can have an address, which is going to be some type of Ethereum address. So we could do address, favorite address equals, and then we can even copy right from our MetaMask and just paste it right in here. This is going to be a valid address here. You'll also notice that we end all of our statements with a semicolon. We can have a bytes object. size 32 bits. Favorite bytes. For our example, we're just going to use the word cat because cat is a string which can be converted down into a bytes object. Byte 32 means that there's 32 bytes in this variable favorite bytes. We can also do bytes 2, bytes 3, bytes 5, etc. with a maximum size of bytes 32. For example, we can't do bytes 64. We're going to be talking about some other variables as well, like arrays and mappings, but let's just stick here for now. If you want to learn more about the different types and the different variables that you can use, head over to the Solidity documentation, and there's a link in the GitHub and the description to show you this section. For now, for our simple storage, let's say we only want to store numbers. We don't want to store anything else. So we're just going to go ahead and delete everything and just have uint256 favorite number at the top. Now in Solidity, if I do this, favorite number actually does get initialized even though I didn't have it initialized to 5. If I leave it blank, it gets initialized to the null value. In this case, it would be initialized to 0. So for now, let's just not initialize it to anything. That way it'll get automatically initialized to 0. This means that when we deploy this contract, as of right now, favorite number will start off as 0. If you get confused, you can also make a comment on this. You could say, this will get initialized to 0. This double slash here is the way to make comments in Solidity, and it won't get executed as code. So we can write whatever we want as long as it's preceded by 2 backslashes. Now let's go ahead and create our first function. Functions or methods are self-contained modules that will execute some task for us. And in Solidity, it's the exact same thing. They're defined by the keyword function. Let's make a function called store that will change the value of this favorite number here. So we're going to call store, and we're going to allow it to be passed a variable. So we're going to allow it to be passed a variable of type unsigned integer 256, and we're going to call it underscore favorite number. We're going to make this a public function, which we'll get to in a minute. And all we're going to do is we're going to set favorite number equals to whatever variable we passed in, favorite number. So this, in its simplest form, is how you can define a function. Now, just to visualize what we're working on so far, let's go ahead and deploy this contract so we can actually start to interact with it. So if we hit this button, this will bring us to the deploy tab and will allow us to deploy our smart contract here. Using our JavaScript VM, it's given us a fake account with some Ethereum in it. It has 100 Ethereum in it to start. And same as before, anytime we want to interact with the blockchain, we have to pay a little bit of gas, even in our fake virtual machine here. And we want to simulate that. So you'll see it has some of the same parameters here as making a transaction, like gas limit, for example. When we deploy a contract, it's going to cost a little bit of Ethereum or a little bit of gas to do so. So let's go ahead and hit this deploy button and see what happens. So once we deployed with this virtual machine, a few things happened. We have Remix kicking out this section down here saying, great job, you've deployed something. And if we scroll down, it says transactions recorded 1. We can look at all the transactions we recorded, and we can see it says deployed contracts, and we have a contract here that we've deployed. Now let's zoom out just a hair here so we can see everything a little bit better. In this simple storage contract, we see this big store button because there's one public function that we can actually interact with. So we can add this number here and we'll hit store, and you'll see again, we have a completed transaction. And if we look at our contract, we'll have paid a little bit more gas, right? We'll have paid a little bit more to interact with this function because again, anytime we want to make a state change on the blockchain, we have to pay a little bit of gas. The reason MetaMask isn't popping up is because we're kind of doing it in this simulated environment. So this is great. However, it looks like we can't actually see what our favorite number is. We can't actually look at it. So how do we actually make sure that we can view this favorite number? Well, let's add another parameter to this as well. If we add public to our favorite number, we recompile by hitting Command S or hit the compile button. We delete this contract and we redeploy and scroll down. Now we'll see 2 buttons pop up. This blue button to show us favorite number, which again is initialized to 0, and we have this store function. So let's talk a little bit about why this public variable allowed us to see this new button, this new favorite number button. This public keyword defines the visibility of the variable or the function. There are currently 4 different types of what's called visibility in Solidity. There's external, public, internal, and private. We're mostly going to be working with public for now, but it's important to note how the rest of these work. Public functions can be called by anybody, including variables. So oddly enough, variables are a function call to just look at them
and return whatever that variable is.
An external function means it can't be called by the same contract. It has to be called by an external contract. So if in this contract, I had this be external, I couldn't call the store function. I couldn't call the store function inside this function because the function is external. It means somebody outside of the contract has to call this function. Internal functions, however, can only be called by other functions inside of this contract or in its derived contract. And then private is the most restrictive, as private functions and state variables are only visible for the contract they are defined in and not derived contracts. Now, the reason that we didn't see favorite number show up in our original contract deployment is that if we don't give a state variable a visibility, it will automatically get set to internal. So if we want other people to be able to read it, we have to change it to public. Now, let's see how this interaction actually works. If we hit the favorite number button right now, we'll get this call thing that shows up, and it'll show us right here that the value of favorite number is 0. Now, this function, however, is set so that whatever value we pass it is going to change the favorite number to whatever we pass it as. So if we pass 1, 2, 3, hit store, that transaction goes through, and then hit favorite number, we can see the value is now 1, 2, 3. Now, I will also be using transactions and smart contract interactions and function calls a little bit interchangeably. That's because on a blockchain, whenever you call a function or whenever you make some state change to the blockchain, you're actually also making a transaction. That's what makes this whole thing so powerful. And again, that's why making a function call or deploying a contract costs a little bit of gas. Now, the reason we can access this favorite number variable inside this function is because favorite number has this global or contract scope. So even if we made uint 256 test equals 4 or equals 4, we wouldn't be able to use this variable outside of this function, right? Because it's self-contained. It's self-contained inside this bracket. And if I were to make another function, store2 perhaps, public, store2 doesn't know that this test variable exists. Functions only know about the variables that are in the same scope as them. So favorite number is in this global scope because the only bracket that's above them is simple storage, and test is in this store scope because it has 2 brackets above it. It's inside of this store function and inside of this contract simple storage. Store2 isn't inside of this store function or this store scope, so it can't access this test variable. So let's go ahead and make this back to public, and we'll compile. Again, I'm hitting Command S to compile, but you can go ahead and click the button if you like. And let's get rid of this and get back. Now, as you saw, when we deploy this, there's this button here that we can click called favorite number. We can also make a function called retrieve and make it a public function that is of type view and returns uint 256. And all this is going to do is return favorite number. So we're going to talk about views and returns here. So I'm going to go ahead and compile. I'm going to go ahead and delete this contract. I'm going to go ahead and deploy it now. And we can see now we have 2 functions or 2 blue buttons here. We have retrieve and we have favorite number. And if I change favorite number by calling the store function, favorite number and retrieve will both now say it's 1, 2, 3. So then the question might be, well, why is this one orange and these 2 are blue? And the key relies in this view function or this view keyword. There's 2 special keywords that define functions that you actually don't have to make a transaction on. And those keywords are view and pure. A view function means that we want to read some state off the blockchain. So we're just reading off the blockchain. If we're reading off the blockchain and we're not actually making a state change, then we don't need to make a transaction. These blue buttons are blue because they are view functions. Public variables also have view functions. That's why both of these are blue. This technically is a view function. And when I click it, I get to view and I get to read the state off the blockchain. Retrieve is the same way. We could have this without a return, but it wouldn't do anything. Pure functions are functions that purely do some type of math. We could have uint256, favorite number, public pure, and just have favorite number plus favorite number. So we're doing some type of math here, but we're not actually saving state anywhere. We're going to do this math, but we're not going to save this favorite number anywhere. We're not going to save anything. Deploy this now, this pure function. We would have this retrieve function, 1, 2, 3. It's blue as well because it's, again, not going to change the state of the blockchain. So view functions and pure functions are both going to have this blue color. Now, the reason that nothing shows up at the bottom is because we didn't return anything. All we're doing is we're saying, add these two numbers together, and that's it. In order for this function to give us something back, we need to have it return something. So if we go back to this retrieve function, we have to define what we're going to return when we're defining this function. So we're going to say this is a public function. It's a view function because we're going to read some state, and it's going to return a uint256. So favorite number is a uint256, so that's what we're going to return. Our public variable favorite name is also a view function that returns a uint256. For now, let's just remove that so we can work with this retrieve function. So let's go ahead and deploy. So now we see we don't have this favorite number button anymore because it is no longer a public function. Because again, it gets initialized to internal, so we can't actually view it. Now keep in mind, later on, we're going to talk about how everything on chain you actually can see, and we'll talk about that a little bit later though. So retrieve is going to do 0, we can call store, and now retrieve is going to be 1, 2, 3. Now this application is great so far. It allows a single person to store a favorite number and then go ahead and retrieve it later, which is fantastic. But what if we want a list of people or a group of people and store their favorite numbers? Or what if we want to associate a favorite number with a single person? Well, what can we actually do? Now we have a whole number of different choices, but the one that we're going to talk about is using a struct. Structs are ways to define new types in Solidity. They're almost like creating new objects as well. So we can create a struct called type people and allow it to start storing a favorite number associated with a certain people. So inside of our struct, we can have different types as well. So we can have a uint256 favorite number, and we could also have a string name. Now we have a new type of type people that has a favorite number and a name inside of it. Now what we could do with the struct is we could say people public person equals people, and then inside we add the variables. So we could say favorite number, favorite number is 2, and name is Patrick. And of course the semicolon at the end. And again, I'm hitting Command S to save, but you can also go ahead and compile in the compile tab. So let's go ahead, delete this contract, and see what this looks like now. So now we've deployed this new contract, and we have this person struct, which at the 0th index is the favorite number, and the variable stored in the first index is going to be the name. Storing variables in Solidity always works in this numeric index fashion. In fact, in contract simple storage, uint256 favorite number is at index 0. If we were to add another object here, like boolean favorite bool, this would be at index 1. If we were to add bool favorite bool 2, this would be at index 2, 0, 1, 2. And it works the same in structs. This is at index 0 inside the struct. This is at index 1 inside the struct. So we can see the variables associated with this person. We're going to go ahead and delete this for now because instead of just creating one person, we actually want to create a whole list of people. So how do we create a list of people? Let's delete that contract. And what we can do is we can make what's called an array. An array is a way of storing a list or a group of some object. So as you're starting to see, the way the syntax works for defining any type of variable is going to be the type of the variable, the visibility of the variable, like public, or if you don't declare it, it gets initialized to internal, and then the name of the variable. It works the same with arrays. So we'll make a people array. The people array is the type. We'll make it public, and we'll call it people. Now if we deploy this contract, we can go ahead and see we now have a people array. But if we click this button, you'll see that nothing shows up. And the reason is because it's an empty array to start with, right? We don't have anything inside of it. Now, this type of array that we've created is what's known as a dynamic array. It's a dynamic array because it can change its size. Right now, it's of size 0, and if we added something to it, it's of size 1. You can also create arrays of a fixed size. So if I were to do people 1, public people, this array could only have a maximum of 1 person inside of it. So we're going to work with a dynamic array though, because we're going to want to add an arbitrary number of people into here. So let's go ahead and create a new function called addPerson, where we can add a person to this array. So we'll do function addPerson string memory name, and I'll talk about this memory keyword in a minute. Uint 256 favorite number. And then we'll make this a public function. And inside, we'll add this person to our array. The way to add a person to your arrays is using the push method. So we're going to push a new people or a new person, and we're going to give it those variables again. So we're going to give it favorite number is this variable that we passed in here. Oops, this needs a bracket. And then we're going to give the name, going to be this underscore name, and then end bracket. Oops. Zoom out again here, just so I can see stuff. This needs a semicolon, and perfect. Now, in that last clip, we saw this little red box pop up. Whenever a little red box like this pops up after you compile, it means you have a compile error. This means that there's something wrong with your Solidity code or your Solidity syntax, and it won't compile and deploy properly. Red is going to be this compile error. Now, we're going to see a bunch of yellow warnings in the future. If you get a little yellow pop-up, these are okay to ignore, but they usually have some helpful tips about something that might be going wrong in your code. So to summarize, if it's red, it's broken. If it's yellow, you might want to check it out, but it could be okay. So we can see we have our new function addPerson, where we pass a string memory name and a uint 256 favorite number. And then we create this people person, this people object here, and then we push it onto our people array. And I'm going to show you another way we can actually create a people person is just by passing favorite number and name. And getting rid of this other bracket by passing favorite number and name. Because we know that the 0th index of people is favorite number, and the first index of people is name. So we can also create a new person by adding it like this. Now let's talk about this memory keyword here. Now in Solidity, there's more or less 2 ways to store information. You can store it in memory or in storage. When you store an object in memory, it actually means that it'll only be stored during execution of the function or of the contract call. If we hold it in storage, that means that that data will persist even after the function executes. A string in Solidity is actually technically not a value type. A string is actually an array of bytes. A variable of type string is actually a special type of array that we can append text to. So because it's technically an object, we have to decide where we want to store it, in memory or in storage. And since we only need this name during the execution, we can have it be string memory name. And then when we create this new people object, we will create a new copy of this name variable into storage. Memory means that after execution, delete this variable, and storage means keep it forever. If this is a little bit confusing for you, just know that for now, when you use a parameter that's going to be a string for one of your functions, you need to call it string memory. So let's go ahead and deploy this contract and see what happens now. Now we have this new function, add person. And since we are making a state change here, we can see that this indeed is a orange button instead of being a blue button. So we can add in here a string name. We'll add Patrick, and we'll say his favorite number is 2. Again, right now, if we look at people, we see people 0, there's nothing in here. If we retrieve, there's nothing in here. So we're going to add person Patrick, and now if we hit people of 0, we can see that the person at the 0th index in this people array is going to be string Patrick. If we try at 1, there's nothing in here. Let's add another person. We'll add Becca, and her favorite number will be 24. Let's add her. Now if we hit 1, we see favorite number 24, string name is Becca. And retrieve is still showing up blank because we haven't touched favorite number. Awesome, this is great. We can just keep adding people. However, there is kind of an issue here. What if I'm looking for a person? What if I'm looking to find Becca and find her favorite number in this array? What if I know her name, but I don't know her favorite number? Is there an easy way for me to find that favorite number without having to triage the entire array? There's another data structure called a mapping. So let's create this new data structure. So this data structure is going to be of type mapping. A mapping takes some type of key and spits out whatever variable it's mapped to. So in this case, if we're saying we want to use the name Becca to find her favorite number, we would say the string Becca is going to be mapped to the uint 256 favorite number. And similar to all the other variable declarations, the first part is going to be the typing. So this is going to be a type mapping of string mapped to uint 256. We're going to give this public visibility, and we'll call it name to favorite number. And without adding any other functions that work with it, if we deploy this, we can see we have this blue button because we're not making a state change, name to favorite number. And if we type in Becca in here, obviously nothing's going to happen because we haven't added this mapping in yet. So in our add person down here, let's even have this add person also add to the mapping. So we can do name to favorite number. And then the key is going to be this name. So of Becca, we're going to say we're going to map the name Becca to the favorite number. Now we're going to go ahead and compile. Again, I'm hitting Command S. Deploy. We can scroll down here. If we look up Becca in here, we're going to get nothing. However, if we add Becca and her favorite number being 24, this add person is going to add it both to the array and to this mapping. Now, if we look up name to favorite number, we see that Becca returns 24. Now, one other thing I want to show you guys, just because compilers are going to yell at you if you don't have them, is typically at the top of these contracts, you'll want to add an SPX license identifier. Basically, Solidity and the Ethereum community found out that trust in a smart contract can be better established if source code is available. And in terms of legality and copyright, it just makes life a lot easier if you add that license identifier right at the top of your Solidity. We're going to use the MIT license identifier because it's the most open license out there. It means, hey, anybody can use this code and we don't care. So you'll see a majority of Solidity contracts have this SPX license identifier, MIT at the top, and compilers will yell at you a lot less. Awesome. We now have a contract that we've decided that we liked. It's got mappings. It enables us to actually store people and their favorite numbers. This is fantastic. We've done all of our testing in this JavaScript VM, and we've decided, you know what? We want to deploy this to an actual testnet or an actual mainnet. How do we actually deploy this so that other people can interact with this contract? We are again going to use Rinkeby because that's what we use to make our first transaction. Now, again, you will need some type of test Ethereum in your testnet wallet. So again, if you get lost, you can always just Google Rinkeby faucet or Rinkeby testnet faucet and find a faucet. Or a better alternative would be to come to the link token contracts in the Chainlink documentation at docs.chain.link and scroll down or just look up Rinkeby. This link token contracts page has the most up-to-date faucets for any testnet that it supports. So for example, we get a testnet ETH faucet right here, which also just happens to be that exact faucet that we used earlier. The only thing you need to change in Remix is we need to change from JavaScript VM to injected Web3. And MetaMask will actually pop up and say, hey, would you like to connect to this application? Anytime you're working with a Web3 application or a web application that wants to access your funds or work with your MetaMask, MetaMask will pop up and ask for authorization first. This is really good so that we know which applications we're actually connected to. So we're going to go ahead and say next, connect, and we can see here that we've even connected here and that our account on the main network has 0 ETH. And Remix even tells us, hey, you're on the main network. So let's go ahead and switch to the Rinkeby network. And we can now see we're on the Rinkeby network and we have 17.74 ETH on this Rinkeby test network. Injected Web3 means we're taking our MetaMask and injecting it into the source code of the browser here. And that's the difference between injected Web3 and JavaScript VM. Web3 provider is if we want to use our own blockchain node or our own Web3 provider. When we do injected Web3, we're saying our Web3 provider is our MetaMask, which will work perfectly for what we're trying to do. So since we already have some tests in Ethereum, let's go ahead and deploy this and see what this would actually look like if we deploy to a mainnet. The process is going to be exactly the same, right? The only difference is we would be on the mainnet instead of Rinkeby. So let's go ahead, hit deploy. We'll uncheck published IPFS, hit deploy. MetaMask will pop up asking if we want to do this transaction because remember, we are deploying a contract. We are changing the state of the blockchain. So we have to pay a little bit of gas fee for it. So we're going to go ahead and hit confirm. And we get a link to Rinkeby Etherscan, similar exactly as we saw before when we made a transaction. The difference here is that instead of sending Ethereum to somebody, we're actually making a transaction on the blockchain to create a contract. After a short while, it will show up here on Etherscan with a success, the number of block confirmations, which again is the number of blocks appended to the block that included our transaction. We see from, which is our account here, and we see to is this new contract that we just created. And we can even click it, and we see that there's this unique transaction hash that created a new smart contract. And same as working with the VM, we have all the exact same functions in here. And you can see if I hit retrieve, these 3 functions, since they're not making a state change, you can just click them and no transactions will be made. However, what do you think is going to happen if I hit store? If you guessed MetaMask will pop up, you guessed correctly. Again, we see the familiar pieces here. We have a gas price, gas limit. Go ahead and hit confirm. We get another transaction here. And once this transaction goes through, we should be able to call our retrieve function and see a new number. If we call it now, nothing shows up because our original transaction hasn't succeeded. But I bet if we look at it now, okay, it's still indexing, but it looks like it's been included. If we hit it now, we do indeed see this value here. And we can do the same thing with adding a person. We'll add Becca. We'll say her favorite number is 24. MetaMask will pop up. We'll go ahead and confirm the transaction. And if I look up Becca and the name to favorite string right now, it's going to show nothing because our transaction hasn't gone through yet. But if we wait a little bit, I should probably spell her name right, we do see 24. And if we look at the 0th index, we also see Becca's been added here as well. Now, all this Solidity code that we wrote, and when we interacted with this blockchain here, all this Solidity was compiled down to the EVM, also known as the Ethereum Virtual Machine. A lot of the blockchains out there today are what's called EVM compatible. And that means that all this Solidity and all these functions that we're creating can still compile down to EVM and deployed on their blockchain. You'll find out a little later when we look to work on a non-Ethereum based chain that we can still deploy our Solidity smart contracts to these other chains as well. but that's a term you'll hear more and more, the Ethereum Virtual Machine, or EVM. Now, take a break, give yourself a high five because you just deployed your first smart contract and you learned the basics, the fundamentals of Solidity. So huge congratulations on how far you've gotten. Now, in our second projects, we're going to take the fundamentals a step further and start going into the more of the intricacies of Solidity. But just as a quick recap, the first thing you always got to do in your smart contracts is name the Solidity version. Then you'll have to name your contract. A contract in Solidity is like a class and defines all the functions and parameters of your contract. There's many different types in Solidity, like unsigned integer, 256, Boolean, and bytes. We can create structs in Solidity. We can create arrays in Solidity. We can create mappings in Solidity. We can create functions in Solidity. View functions don't make a state change. Memory and storage are two different ways to initialize where a variable is going to be saved. All the Solidity code that we're working with gets compiled down to the Ethereum Virtual Machine. And last but not least, congratulations on taking your first step in learning Solidity. Let's move on to the next project. All the code, tips, and links that we're going to be working with can be found in our course repository. We can scroll down to Lesson 2, Storage Factory, click it here, and we can see all the code we're going to be working with. Good luck. All right, so we've done it. We've got our first contract out of the way. We're understanding some of the basics of Solidity. Now let's move onward. Let's get a little bit more advanced with what we're going to do with our smart contracts. And let's build what's called the factory pattern of smart contracts. So we have our simple storage contract here, which is great. It allows us to store numbers and store favorite numbers associated with different people, and this is great. What if, though, I want to have a lot of these simple storage contracts deployed? I want to give people the ability to generate and deploy their own lists based off of this contract. This is where the factory pattern comes into play. So let's go ahead and create a new contract. So in this contracts folder, I'm going to do new file. We're going to call this storage factory.sol. And now we'll have a storage factory.sol. Now the way that we're going to do this is that you need simple storage and storage factory in the same folder. I have both of them in this contracts folder, but if you have them outside or in a different folder, that's okay. Just make sure wherever they are, they're in the exact same folder. So let's figure out how to get a contract to actually deploy another contract. We're going to add those basic pieces that we added in that simple storage.sol. We'll add the SPDX license identifier, which will be MIT. We'll choose our Solidity version, which will be Pragma Solidity, and we'll say anything in the 6 range. And then we'll create our contract. We'll say contract storage factory, and we'll create our brackets here. And I'm going to do Command S or compile, whatever you want to do. Things are looking good here. Great. So how can this contract deploy a simple storage contract? Well, the first thing that we're going to need to do is actually import this simple storage into our storage factory contract. We need to import it so that our storage factory contract knows what a simple storage contract even looks like. The way that we can import it is by doing the command import and then the file path that the simple storage is located. So the file path for this is going to be at ./simple storage.sol. This means that simple storage is in the exact same directory as storage factory. Doing this line is equivalent to copying everything in this contract bit, coming over to storage factory and pasting it above. You can even save and compile and have 2 contracts in the same file. Now what's interesting about having 2 contracts in the same file is that when you go to deploy, you'll actually have a choice of which one you want to deploy. And it's the same thing if I do that import statement. So if I delete all this and I go back to import./simple storage.sol, in our deploy tab still, you'll see that we still have our choice of which contract we actually want to deploy. So this is how we actually import a contract or import any type of file that we want so that our contract knows what that contract looks like and can do. So if we want this contract to then be able to deploy a simple storage contract, we're of course going to have to create a function that can do that. So we'll do function. We'll call it create simple storage contract. We'll make this a public function. We'll do our little open and close bracket in here. The way we can generate a contract of simple storage type is by using a new keyword. So let's create a simple storage variable. We'll say a variable of type simple storage contract. We'll name this variable simple storage with a lowercase s equals new simple storage. What this line is saying is we're going to create an object of type simple storage contract. We're going to name it simple storage with a lowercase s. And we're going to say this is going to be a new simple storage contract. And we're saying this simple storage contract takes no input parameters. Of course, if we deploy this contract as is by going to our deploy tab, choosing the storage factory, staying on a JavaScript VM, deploying, scrolling down, we have this function that doesn't return anything. So we're creating new contracts, but we can't really read where those contracts are being created. We'd have to look on a block explorer like Etherscan or something. So let's make a way for us to keep track of all the different simple storage contracts that we deploy. Let's put them in a list or in an array. So what we can do is we can say simple storage array of visibility public, and we'll call it simple storage array. We'll initialize this simple storage array, and every time we deploy, we create one of these new simple storage contracts, we'll add it to our simple storage array. So we'll do simple storage array dot push, and we'll push this simple storage variable. So again, I'm compiling or hitting Command S, delete that most recent contract. We'll choose the storage factory and not the simple storage, and we'll hit deploy. Now, if we scroll down to our storage factory, we have this blue button, which stands for our simple storage array. If we try to see what's at index 0, we get an error, of course, because we haven't added anything to it yet. If I click this create simple storage contract orange button here, now I've created a transaction that's going to create a new simple storage contract and push it onto our simple storage array. Now, if I try to access the 0th index or the first index of this array, I'm going to get this address here. This is the address that this simple storage contract was deployed to. So we've successfully deployed a contract to the blockchain from another contract. And this, of course, is really exciting. Now, we can actually do more than just deploy the contracts. We can actually deploy contracts from another contract and then call those functions as well. So let's create a new function where we call this store function, and we'll also create a function where we call the retrieve function from our storage factory. So we'll do function storage factory store. We're going to shorthand it by saying SF store. We'll have it take uint256 simple storage index and a uint256 underscore simple storage number. We'll make this a public variable as well in our little brackets here. And the reason I'm choosing a simple storage index is because we're going to choose which simple storage contract in our list that we want to interact with. And then we're also going to pass a simple storage number to call on the store function, which of course we need to pass a favorite number to. Anytime that you interact with a contract, you need two things. You need the address of the contract you want to interact with, and you also need the ABI. For us, we figured out that we're going to push and get this address from this simple storage array. We can get the ABI, or the application binary interface, from this import. We'll explain the application binary interface a little bit more later. For now, just know that in order for us to interact with this simple storage contract, we can just do simple storage, and then we'll pass this simple storage the address of that simple storage contract. To get the address of that simple storage contract, we'll say grab the address inside the simple storage array at index simple storage index. This will return that contract that we want to interact with. So we could even say simple storage equals simple storage at that address in the array. Once we get this contract, we can then call any and all of its functions. So we could call simple storage dot store this simple storage number. Now, if we compile this, we go to our deploy tab, deploy the factory, hit deploy, open this up, we can see we have a couple different functions here. We, of course, have our create simple storage function, which creates the contract and adds it to our array. We now have this SF store, which stores a number to one of those contracts on this array. And then we have a lens into that simple storage contract. So if I create a simple storage contract, I can now store on that 0th contract, on that first contract, any number that I want, like 55. Of course, I can't really see that 55 because we didn't add a retrieve functionality. We didn't add a way to actually listen or read or retrieve that favorite number that we got. So let's add that now. So we'll create a new function called sfget, and this will take a uint 256 simple storage index and as a parameter, and we'll choose one of these contracts on this array and return its favorite number, calling the retrieve function on that contract. So since we're just going to be reading state, this can be a public view function that will return a uint 256. To do this, we need to access that contract once again. So we'll say simple storage equals simple storage at that address of simple storage array at index underscore simple storage index, and we call, and we can return simple storage dot, we call this retrieve function. I'm just going to copy paste it so I don't spell it wrong. Simple storage, we'll put the semicolon here too, and here. Now, if we compile this, go to our deploy tab, delete the most recent, choose the storage factory, and hit deploy, we can see we now have an sfget function. So let's go ahead, create a simple storage contract. We'll store a function on the 0th contract. We'll store 55 as its favorite number, and we'll hit that. And then for sfget, we'll see if we can get the favorite number of the 0th contract. And we do indeed get 55. Awesome. We can actually even refactor this code to be a little bit simpler here. We don't need to save this simple storage contract as a variable here. We can actually just call retrieve on this whole section here, paste retrieve at the end, and just return like this. The same goes for our SF store. We can delete, saving it as a variable. We can copy this dot store, paste it at the end here, and delete this as well. Now we'll compile, delete the most recent. We'll deploy the storage factory. And if we go into it, create a simple storage, store the number 55, see what's at the 0th index, and we do indeed see 55. So this is really cool. This is a way for us to actually deploy contracts and interact with contracts from another contract. Now, to deploy a contract, we do need all the functionality of that contract imported. However, to interact with a contract, we don't need all of the functionality. We'll learn about interfaces in the next lesson, which will allow us to actually interact with a contract without having all of the functions defined. And now I'm going to show you something really cool. Simple storage has got a lot of really cool functions, and maybe I want all these functions inside my storage factory. I want my storage factory to be able to create simple storage contracts, and I want it to be a simple storage contract itself. Well, what I can do is my storage factory can actually inherit all the functions of simple storage without me having to copy paste all these functions and all these variables over to storage factory. What I can do is I can do Solidity's version of inheritance. I can say contract storage factory is of type simple storage, or is of contract simple storage. And just by doing this line right here, my storage factory contract now will have all of the functions and variables of simple storage. So it'll have a store function, a retrieve function, an add person function, a people array, a name to favorite number mapping. It'll have everything because I will inherit it with this is syntax. So if I go to my deploy tab now, let's look at what our last storage factory was. All we did to change this was add is simple storage, and we can see just the 4 functions that we originally added. If I delete this now, if I save and compile the storage factory, let's go ahead and deploy storage factory. If we open this up now, we can see not only do we have all the functions originally defined in our storage factory, but we additionally have all the functions from our simple storage. And awesome, you've completed the second lesson. We've learned about some incredibly powerful tools here. We've learned how to import entire chunks of code from other files into our files. We've learned how to do inheritance. We've learned how to deploy contracts from our contract. And then we've learned how to interact with different contracts from outside of our contract. Well done. Now is a great time to take a breath, take a breather, and review what you've learned. The GitHub repository associated with this course also has all the code for this lesson. So let's jump into it. So we're back in Remix now, and we're going to go to contracts, and same as before, we're going to create a new file. We're going to call this fundme.sol. Now, same as last time, we're actually going to add this SPDX license identifier, MIT right at the top, and then we're going to choose our Solidity version. So we're going to go Pragma, Solidity, and for this, we're just going to do greater than or equals to